Dear students, I am Santa, working as a physics faculty in Target English Medium School. Today, in this part video, I would like to teach another chapter in 8th standard level in our physics subject. The chapter name is Sound. First, in this chapter, we are discussing about what is the sound and how it is produced. Further, we are going to discuss how the sound is traveled through the air from one place to another place. So, generally, we know that sound is a form of energy. It causes sensation of hearing, that is we know very clearly. So when any body is produced the sound is reaches to our ear is nothing but what is the meaning of that one. So okay, the sound is the one of the form of energy in the nature. With help of the sound only we are hearing anything. That is the meaning of that. Sound is a form of energy. It causes the sensation of hearing. But how the sound is produced? Sound is always produced from vibrating bodies. Sound is a form of energy. Really, sound has the energy or not? We discussed one or two experiments in this video. Next, sound is always produced from vibrating bodies. So first of all, we discuss in that. Okay, sound is produced really from the vibrating bodies or not. After that, we can go for sound is a form of energy or not. Sound is produced from vibrating bodies. Sound is produced from vibrating bodies. We discussed 2 or 3 examples for this time. Simply, so I will explain clearly with 3 examples to understand. Really, sound is produced from vibrating objects or bodies. Tuning fork. It is the shape of the tuning fork. So what is the shape? It is appears like a U shape. It will be having one handle. These two we are called as prongs. It is the what is that one means? So head of the tuning fork. So these two are the prongs of the tuning fork. It will be having one rigid support. This rigid one we can hold in your hand, and with help of a rubber hammer we hit the any one of the prong, either left hand side or right hand side. They start the vibration and produce the sound. So listen very carefully. Tuning fork is one of the sound instrument. With help of the tuning fork, means first of all we can hold the tuning fork, and now we can take a rubber hammer. With help of the rubber hammer we can strike the any one of the prong. Then the tuning fork will be start the vibrating, and we hear the sound. But generally its frequency is very high. That's why that high frequency of the sound we are not able to hear immediately. So that what we can do means it is produce the less, means its frequency is 512 like that one only, but that's sound we are able to hear, but it is produce little bit energy of the sound. That's why. So after hit the tuning fork of the prongs with help of the hammer, it will be bring near to your ear. At that time you are hear the sound. Listen very carefully. First we can take the tuning fork, it will be hold in your hand, and before striking with the rubber hammer, it bring near to your ear, you are not able to listen any sound. Now in the second time, now we can hit the prongs of the tuning fork with help of the rubber hammer. After that it bring near to your ear, you are observing that. So you hear the sound, but with visually the tuning fork is not appear to in a vibratory motion, but it is produce the sound. But really it is vibrate or not means with help of the microscope we are clearly observing that. So the tuning fork will be vibrated from its main position is nothing but when you can hit the tuning fork prongs with help of the rubber hammer, the tuning fork will becomes to the oscillatory motion and produce the sound. That sound will be reaches to us, our ear, when it bring near to your ear. So it's nothing but here. So are you able to hear the sound or not? Yes, we are able to hear the sound. When after striking with rubber hammer, when you can striking with rubber hammer, what will happen? It start the vibration. So it's nothing but the prongs will become to the either oscillatory or vibratory motion. Oscillatory motion is nothing but so the body will be moved to and fro motion from its main position is called oscillatory motion. Vibratory motion is also nothing but, so the body is vibrated so forward and backward or up and down from its starting main position is called vibratory motion. That's why the tuning fork will be started comes into the vibratory or oscillatory motion and it will produce the sound. That sound reaches to us when we bringing near to your ear. Second one, a string fixed between the two rigid so two rigid ends. So it is the one rigid end, it is another rigid end. We consider that like this one. You can fix a uniform string like this one is there. Uniform string. Now we can take a paper. The paper is cut into the riders like this one. These are called paper riders. Means you can cut into the like a rectangle small breadth of the rectangle. So like this more very tiny rectangular shape. So breadth is very small, length is more. That type of way you can cut the paper, that is called paper rider. It will be folded at the middle and it will be placed on the string. So first of all we can take the uniform string. The two ends of the string is fixed to the two rigid supports. Now we can take the two paper riders. The paper riders are placed on the string. Initially you are observing that the paper items are in rest position. Is nothing but the paper items are not having any disturbance, are not moving on the string. So at that time, what you are understanding that the string is not in vibratory motion, it is in the rest position. Now with help of your finger, slightly you can plug at its middle, then what will be happen means the string will be start the vibratory motion and the paper ends will be jump up and down slowly. So means here when the paper ends will be move up and down means what you are observing here, before plug the string with help of your finger gently, at that time the two paper riders are in which position? They are in up rest position. But when you can plug the string slightly gently with help of your finger, you are observing that paper riders are moving up and down, is nothing but like jumping. So means here the jumping of the paper riders are represented, the string is in the motion. Which motion? It is in vibratory motion. So that's why at that time we are hearing the sound also. So that's why when the string is in the vibratory motion, it will produce the sound. Why we can take this one means generally the string is not appeared to into the vibratory motion for our human eye by applying a little bit force. That's why. So really the string is during the producing of the sound, it is in the vibratory motion or not, or it is vibrate or not. For checking of that one, we are using which one? Paper riders. That's why the jumping or the moving of the paper riders are represented. The string is in the vibratory motion or is vibrate. That's why it produces the sound. Next, one more thing is also a guitar. Most of the cases in the string instrument, guitar, violin, veena, like that one. So first of all, we can take a guitar. The guitar will be having the high tension strings are there. When slightly we can plug the string of the guitar, it produces the sound. Not only the guitar, veena, violin also we are observing that. That's why the string of the guitar or the string of the violin or string of the veena, when you can plug gently, you are observing that they start the vibration and produce the huge sound. Pleasant sound. Anyone? So along with that one more simple thing I will explain that if you can take a blade, the blade will have the two ends. One end of the blade, we can keep into the between your teeth, and another free end is there. So the another free end is gently pluck with your finger. The blade will start the vibration and produce the sound. In certain movies also we are observing this type of process. So listen very carefully. Sound is a form of energy. It causes the sensation of hearing. Sound is always produced from the vibrating bodies. Is really sound is produced from the vibrating bodies? Means yes, sound is produced from the vibrating bodies. So first of all, we can take the tuning fork. You can hold the tuning fork and strike with a rubber hammer. After striking with a rubber hammer, the prongs of the tuning fork will be bring near to your ear, so you hear the sound. At that time, the tuning fork will start the vibration. Next one. You can take a uniform length of the string. The two ends of the string is connected to the fixed rigid support and place two paper riders at its corners. Now gently you plug the string at its middle. You are observing that it produces the sound. At that time the string is in vibratory motion or vibrates. That really it is in vibrate or not, with help of our human eye we are not able to see. That's why we are using the paper riders. When you can plug, the paper riders are move up and down. At that time it produces the sound continuously. When the paper riders are not move up and down, again comes to the rest, it cannot be produced any sound. That's why when the body is in the vibratory motion, it produces the sound. When the body is in the rest, it cannot be produced the sound. Next, if you can observe a guitar, first of all you can take a guitar or violin or string. Now gently you can pluck with your finger. They start the string in the guitar or violin or veena. It will start the vibration and produce the sound. That's why a vibrating body must be produce the sound. Next, we discuss that how does sound travels in air? After this one, I will explain clearly. Sound has a form of energy. So, how does sound travels in air? So, we know that, okay, in a classroom or in the open auditorium, or okay, you are observing that when during the conversation with another peoples or with your friend, so between you and the friend, what is there? Air is there. In a classroom, during the when any teacher will be teach the explain any topic on the blackboard. At that time, the students are sitting in the chairs. Between the students and the teacher, which is acts as a medium, air is acts as a medium. What the teacher is said or what the teacher is pronounced, so through his mouth, that words are reaches to the every student in the room. Okay, so between the students and the teacher, which is acts as a medium, air. So it's nothing but, listen very carefully. Sound is a mechanical wave. That is first thing. Sound is a mechanical wave. Mechanical wave is nothing but a wave which require a medium for their propagation. Propagation is nothing but to move from one place to another place. Listen very carefully. A wave which require a medium for their propagation, that waves we are called mechanical waves. Mainly two types of waves we are observing, that mechanical and electromagnetic waves. Electromagnetic waves is nothing but a wave which require a wave propagate from one place to another place without any medium. Listen very carefully. A wave which require a medium to propagate, that is the mechanical wave. A medium without any medium also, it will be propagate from one place to another place, that is called electromagnetic wave. Simply, light waves are electromagnetic waves, sound waves are mechanical waves, because of sound is travel from one place to another place when medium is present. If the medium is exists in that one only, sound will be travel. In the absence of the medium, sound cannot be travel. It's nothing but in a vacuum, sound cannot be travel. For that one, I will give one explanation in later further videos. So first of all, we discuss that sound is a mechanical wave. The mechanical wave further classified into the two types. Progressive waves and stationary waves. The progressive waves further classified into the two types, longitudinal wave and transverse wave. So our sound wave is belonging to the longitudinal. Is nothing but is the one of the propagation wave. So listen very carefully. Sound is mechanical wave. Mechanical wave is nothing but it must be require a medium to move or to propagate from one place to another place. But the sound is under the mechanical it is which type of wave, means it is a longitudinal wave. So mechanical wave further classified into the how many types? Two types. Propagation and stationary waves. Sorry, progressive waves and stationary waves. Progressive waves further classified into the two types based on the vibrating position of the particles. First one is the longitudinal wave and second one is the transverse wave. Light is a transverse wave and the sound is a longitudinal wave. Under the mechanical, it is which type of one? Longitudinal wave. Which wave we are called as longitudinal wave means the position of vibrating particle or the particle in a medium vibrates parallel to the direction of the propagation of the wave is called longitudinal wave. Listen very carefully. So the vibrating particle in a medium parallel to the direction of the propagation of a wave, That waves we are called longitudinal wave. The vibration of a particle in a medium perpendicular to the direction of the wave, that waves we are called transverse wave simply. It is the direction of a wave. For the direction of the wave, if the vibration of the particle is up and down, so means for the direction the particles are moved either up or down, means for this one it is which one? Perpendicular, that is the transverse wave. But for the direction of the propagation of a wave, the particles are so like this one means parallel. So for the direction, the particles also vibrated parallel. So that's why this is the longitudinal, it is the transverse wave. Once again listen. Sound is a mechanical wave. Mechanical wave is nothing but a wave which requires a medium for propagation. So that's why sound needs a medium to move from one place to another place, that is either solid or liquid or gas. That is one is there. So now at the same way, mechanical wave further classified into the how many types? Two types: progressive waves and stationary waves. So progressive waves further classified into the two types: longitudinal and transverse. So our sound waves are mainly belonging to which one? Longitudinal. That's why I will explain the longitudinal. Longitudinal is nothing but the vibrating of the particles in a medium. The vibrating particles in a medium is parallel to the direction of the propagation of the wave. For the direction of the propagation of the wave means wave is moving like this one, this is also moving like this one, that is called parallel, that is the longitudinal wave. But the transverse wave means wave is traveling like this one, but the particles are moved up and down, like that one. So generally this type of one we are observing that if you can take a rope, one end of the rope will be connected to the rigid support and another end is holding your hand tightly. Now at another end just you can wave the rope will be moved like this one. So it's nothing but here. So from our hand to rigid support, the initially before wave the rope is up straight. So that's why that is the direction of the wave. Direction of the wave means from our finger to rigid point. That's why direction is like this one. For the direction of the wave, when you can start the vibration of the rope will be moved like this one. Is nothing but so for the direction the rope particles are up and down is nothing but perpendicular. But in this one it will be parallel like a slinky. Slinky means so you are observing that if you can hold in your hand like this one, like spring like that is there. You can hold in your hand. So if one hand is fixed, another hand is moving. Now the slinky is moved like this one. You are observing that the slinky is just you can push this one, it will become like this one and come. Means so here what is the direction from here to here? This is the direction. For the direction the slinky will be moved, compression, rarefaction. Compression, rarefaction is nothing but the so the particles in the sink will be parallel. Means for the direction it is the parallel only. So that's right. So I will explain how the sound is travel in the air in the form of longitudinal wave. So that is I will explain in the next video. Once again listen. Sound is a form of energy. It causes sensation of hearing. Sound is produced from the vibrating bodies. If a body is vibrate, it produces the sound. For that one, so if you can take a guitar, the string in the guitar, gently you can flick, the string will start the vibration and produce the sound. A string which is fixed between the two rigid support and place two paper riders on it. Gently you can pluck at its center or middle, so the string is start the vibration and produce the sound. The vibrations you are observing in the form of motion of the paper riders. You can take a tuning fork. The prongs of the tuning fork are strong. Strike with a rubber hammer. At that time, the prongs of the tuning forks are very near to your ear. You hear the sound. That's why if a body is vibrate, it produces the sound. Next one. How the sound is travel through the air is nothing but for that one. Before that, I will give a small explanation or introduction about that one. Really, sound is a mechanical wave. Mechanical wave is nothing but it requires a medium for their propagation. It's nothing but if the sound is a travel from one place to another place, it must be needs a medium that is either solid or liquid or gas. If the medium is not present or in absence of medium or vacuum, the sound cannot be travel. That is I will explain later with help of electric bell jar experiment. And mechanical waves are further classified into the two types, progressive and stationary. Progressive are further classified into the two types, longitudinal and transverse wave. Our sound is mainly the sound travel. Our concept is how does sound travel in the air? The sound is travel through the air in the form of longitudinal wave. Means sound is which wave? Longitudinal wave when it is travel from one place to another place in the air. That's why sound is one of the longitudinal wave. It will be travel from one place to another place in the form of compressions and rarefaction. So what is the compression? What is the rarefaction? That is I will explain in the next video. Thank you.